Hi, this is Neel and this is my DSF traffic simulation lab. Here is my intersection. As you can see, these pins represent whether or not there is traffic coming in that direction. So over here we have traffic coming down on Bravado south and wanting to go straight, and over here we have traffic going down on Bravado and wanting to turn left. If, let's say, I put a 1 on traffic going south on Bravado wanting to turn left, and I tick forward in the clock, you can see that this light goes down to yellow, then to red, and it circulates throughout the intersection, and then when it eventually gets to this left turn, because there's traffic coming through, even when I continue ticking, the light stays green because there's traffic wanting to turn left. Now, let's say I wanted someone to, let's say there was traffic coming west on Academic Boulevard, and let's say right now that there's no more traffic wanting to turn left from going southbound on Bravado. If I do that, then if we tick, you will see that the left arrow on Bravado southbound has gone to yellow, and then one more tick and it goes to red. Over here you can see that it's green now and there's traffic going westbound. So even if I tick, the traffic light doesn't change until when I switch off the westbound traffic on Academic going straight, it goes back to red through yellow. I'd like to explain what's going on in this finite state machine for the simulation circuit. Over here we have our next state logic. Here we have our registers connected to the clock with the data input for the next state from the next state logic. And then here we have output logic, which essentially decodes it into the LED patterns shown here. The inputs to the next state logic are based on whether or not there is traffic at each one of these nodes. So if I go into my next state logic circuit over here, you can see that I have the 8 possible inputs, and correspondingly I have OR gates for eastbound straight traffic and westbound straight traffic, because if there's eastbound straight traffic or westbound straight traffic, the light is supposed to stay green for that. Same with the lefts going either way and the south and north going either way. So when I put this into my circuit, I created essentially a diagram to show the flow of the logic from state to state in the finite state machine, and I created the corresponding truth table for the next state logic and derived the logic functions, and then I implemented those into this circuit so that S2 prime, S1 prime, and S0 prime are essentially a 3-bit combination which tells me which state to go to after this. If I go back to my main, the next state is entered into these registers, and on the rising edge of the registers, when I tick the clock, after I tick the clock and it's on the rising edge of the register, this data is transferred over here, right? And this is essentially, this next state becomes the current state, which is then fed back into this, and based on the inputs and the current state, the next state is produced and held here while this current state is occurring. This current state is an input to the output logic, which essentially implements that specific state's corresponding traffic light combination.